Hello.
Professor Agrawal join কৰিছে নেকি নবাংকুৰ?
Yes, sir.
Professor Sanjay Agrawal, good evening.
Hello.
Hello, Professor Sanjay Agrawal, good evening.
Good evening. Good evening.
Yeah, good evening. Okay, we are just starting. Yeah,
Many person are trying to attend. So I have to admit all the candidates, or you are going to admit?
we are going to admit.
We are going to admin. We just make you co-host so that all the links are active for you, sharing of screen and all.
Can we start, sir?
Yeah, we can start.
We can start
now.
Good afternoon, ladies and gentlemen. I extend a warm and gracious welcome to all of you on behalf of Krishnakanto Handik State Open University. I am Redip Dev Chaudhary, Director in charge of Hiranya Chandra Bhuya School of Science and Technology. And it is my privilege to be here today to introduce our esteemed guest, Professor Sanjay Agrawal sir. I extend a special welcome to Professor Agrawal sir, and I am grateful for his presence here. Today, as we gather here, the world is celebrating World Environment Day. In commemoration of this significant occasion, the Hiranya Chandra Bhuya School of Science and Technology at our university has organized an enlightening online talk. So originally, we had planned to conduct this talk in a physical face-to-face setting at our university premises. However, due to the holiday commemorating the birth anniversary of Sri Sri Madhav Dev, we have had to make the necessary arrangements to shift the event to an online platform. Now I kindly request Dr. Shruti Sruba Bharali and Dr. Tapasi Kashyap Das to coordinate the session. Over to you, Dr. Shruti Sruba Bharali. Thank you.
Thank you, sir. Good evening, everyone. First of all, I would like to request our senior most professor, Professor Nipendra Narayan Sharma sir, to say a few words.
You are not audible.
Professor,
your internet connect.
My screen is visible to you.
Yeah.
I think the audio is not clear.
I think sir has lost the connection.
Okay. So we shall wait for 2 minutes so that sir can rejoin and then give his welcome speech.
My screen is visible to you.
Yeah, yes, sir.
Yes, sir, it is visible. Sir, we are waiting
Actually,
for
many
Sarma sir to-
participants are coming and they are in the waiting room.
Yes, sir, we are admitting them one by one.
Am I audible, Shruti?
Yes, sir, you're audible. Yes. So please give the welcome speech.
Okay. Okay.
I think we should start now.
Okay, okay. Thank you. Sorry for the okay. Still, this is indeed a pleasure on behalf of KK Hendricks State Open University to welcome all of you to this distinguished speakers talk on a particular topic which is very important on today's occasion on World Environment Day. Professor Sanjay Agarwal is a distinguished speaker. He has got expertise in the field of electrical engineering, more especially in be speak on as we all know energy and we come at so many things ammonia projects we talk about the solar and improving the solar system. So I will not just prolong my welcome address because the internet connection is quite unstable here in my front. So I just straightway would like to extend our warm welcome to Professor Sanjay Agarwal and as well as all other participants so that we can have a very meaningful discussion on this particular topic. So once again, I would like to extend our warm welcome and thank you all. Thank you, Dr. Shruti. Yeah.
Thank you, sir. I
Thank
would
you.
now like to introduce our invited speaker for today's program, Professor Sanjay Agarwal Sirji. Professor Sanjay Agarwal sir is the Pro Vice Chancellor of Chhattisgarh Swami Vivekanand Technical University. He had worked as a professor in electrical engineering, School of Engineering and Technology at IGNOU, New Delhi. He is the recipient of prestigious Bhaskara Solar Energy Fellowship from the Indo-US Science and Technology Forum and Department of Science and Technology, India. Professor Agarwal sir had done his postdoctoral fellowship from Smart Grid Energy Research Center, University of California, and received his PhD degree from IIT Delhi. Sir has more than 20 years of teaching and research experience with specialization in electrical engineering. Sir has published more than 80 papers in international journals, authored 3 books, and developed 2 MOOC courses on principles of electrical science and renewable energy technologies and their uses, which are available in the SWAYAM platform. He has also published a patent titled Improved Hybrid Solar Collector. Some of his areas of interest include grid-connected photovoltaic system, microgrids, and solar PV water pumping systems. I now request Professor Sanjay Agarwal Sirji to kindly deliver his talk.
Thank you very much. First of all, I would like to say happy World Environment Day to you. And I would like to convey my regards to Honorable Vice Chancellor of the University, who has given me this opportunity to speak on this important day. So as you know, every year on the June 5th, people, communities and organizations from all over the world come together to celebrate World Environment Day. And why this World Environment Day is celebrated? It is celebrated to raise awareness of and take action on urgent environment challenges. The United Nations created this important day to raise awareness of pressing need to safeguard and conserve our planet natural resources. The World Environment Day gives individuals a chance to consider how human activity affect the environment and motivates them to change for the better in order to live properly. It acts as a catalyst for the international discussion, teamwork, and the efforts made together to create a greener and more sustainable future for generation. Now, we have to understand what is the basically environment. So environment can be defined as a sum total of all the living and non-living in an element, and they are effects that influence human life. While all living or biotic elements are animals, plants, forest, fishes, bird, and non-living things. So basically, if we are talking about the environment, so it includes water, land, sunlight, energy. So here our focus is basically on this particular topic is energy, right? So if we are talking about the energy, so first term that come in a picture, that is solar energy. Or if we're talking about the solar energy, that means photovoltaic solar system comes in the picture. So here you can see the topic that I have chosen is hybrid photovoltaic thermal system, right? So hybrid photovoltaic thermal system, now we have to understand what is this hybrid photovoltaic thermal. So you know very well that photovoltaic means what is what if solar energy is converted into electrical energy by some means, that is called basically photovoltaic. Now here you can see this term is hybrid. So hybrid means what? Hybrid is nothing, it is a mixing of two basically two technology. So here another term is coming thermal. That means by this system, you will get two type of energy. One is electrical energy due to this photovoltaic effect. Another is thermal. That means by this system, you will also get some thermal energy. So basically you can understand that suppose this one is a one solar cell, right? I think you, am I visible to you? You can see this mobile. This one is a basically solar cell, right? So what happens as solar radiation incident on this solar cell, so it is just like a PN junction diodes. It converts into electrical energy. So basically what happens as
The
we
slides are
say,
not moving.
as we
The
say
slides.
that electrical efficiency is 20% or 25%. So what is the meaning of this basically? That means if you are giving 100% and out of 100, just you are able to convert just 20%. So what about that 80%? That means this 80% is just wastage. It is converted into heat, right? So what happens basically as solar energy incident on the solar cell, right? So as you know, the electrical efficiency of the solar cell basically depends on different parameter. One important parameter may be the solar radiation. So as solar radiation increase, the electrical efficiency increase. But at the same time, whenever the more solar radiation is there, that means temperature will also increase. If temperature of the solar cell is increasing, that means what will happen? As I already told you, it is just like a PN junction diode, right? So as temperature is increasing, the net flow of electron is getting disturbed. If net flow of electron is getting a disturbed, that means you can say basically current is what? Current is nothing, it is a just flow of the electron. If flow of electron is getting a disturbed, that means current is going down. If current is getting down, that means output power will decrease, because as you know, power is what? It is very simple formula, no need to understand any engineering. Just you have to understand very basic science. Power is what? Power is nothing. It is a product of voltage and current, right? So as I told you, as the temperature is increasing, that means net flow of electron is decreasing. If net flow of electron is decreasing, that means current is decreasing. If current is decreasing, that means output power is decreasing. Now, that means we can say this temperature is basically one dangerous phenomena, which is responsible to decrease the electrical efficiency of the solar cell. That means if we know the problem, we have diagnosed what is the problem, right? If you go to the doctor, what doctor does basically, just he try to find out what is the problem, what is it, if your temperature is more or there is some infection in the blood. So similarly, we can understand that one temperature is also a one phenomena which is responsible to decrease the temperature of the solar cell. That means if we can decrease the temperature of the solar cell by any means, that means we can say we can increase the electrical efficiency of the solar cell. So generally, if you go through the literature, it is said that if 1 degree centigrade temperature is increasing above the standard temperature, like you can say standard temperature is 25 degrees centigrade. If temperature is more than, suppose 2 degrees centigrade by the 25 degrees centigrade, so 1 degree centigrade temperature is increasing, we say that
Sorry to interrupt you, sir.
0.4% electrical efficiency is going to down, right? So
Sorry to
that
interrupt you,
means we
sir.
have to
Sir,
control
your
the
slides are not
temperature.
moving.
So whenever we say that electrical efficiency of the solar cell is 20% or 25%, so it is always said it is always at standard test condition. And what are those standard test condition? If ambient temperature, that means whatever the temperature is you are feeling outside or in the environment, that is called ambient temperature. If ambient temperature is 25 degrees centigrade and solar radiation is 1000 watt per meter square, at that time you will get the maximum electrical efficiency. Like you can understand like that whenever we purchase any bike or car, we said the average of this car is 15.
Excuse me,
That
sir.
means yes.
Sir, the screen, the slides are not moving.
No, just I am on the first slide only,
Okay, sir. Okay.
right?
Okay, sir.
So we say that average of that car is gives the 15. That means that car runs 15 kilometer in 1 liter, but it is always that standard test condition. If you are running this car around 40 to 60 kilometer per hour speed, then it is said, right? Now, what will happen? Similarly, if we say that electrical efficiency of solar cell is 20%, so it is always at standard test condition. And what are those standard test condition? If solar radiation is 1000 watt per meter square and ambient temperature is 25 degrees centigrade, right? So what we can do basically, so suppose this one is a solar cell, right? So just you make a one channel below the solar cell, or you can say you make a one duct below the solar cell and just you force the air, right? So you force the air through the duct. So what will happen? This ambient air will come in the contact of the base of the solar cell. Then what will happen? It is a very basic simple formula. That means heat always transfer from higher temperature to lower temperature, right? So what will happen? This cool air will come in the contact of the base of the solar cell. So heat will be transferred from back surface of the solar cell to the air, right? So what will happen? That means heat is going to transfer to the air. That means temperature of solar cell is decreasing. If temperature of solar cell is decreasing, that means you can say you are able to increase the electrical efficiency of the solar cell, right? Now, this is one way how you can increase the electrical efficiency. Now, what will happen? Because you are forcing one air at the inlet point and you can collect some hot air at the outlet point, right? So that means if you are able to collect some hot air at the outlet point, that means hot air is what? Hot air is nothing. It is basically, you can say, this is thermal energy, right? So by this system, you are getting two type of energy. One is electrical energy due to this photovoltaic effect, and another is thermal energy due to this thermal effect. That's why this system is called hybrid, because hybrid means mixing of two. So this is all about the topic. I think topic is clear to you. Now just I'm moving. As I already told you, what is a basically solar cell? Solar cell is nothing. It is just a, you can say it is a p-n junction diode, N type and P type. As solar radiation incident of the solar cell, so it will be able to convert solar energy into electrical energy. This is very basic principle. Here you can say, now whenever we talk about the solar cell, sometimes we say it is a photovoltaic module, sometimes it is said it is a array. So cell is what? Smallest unit of any photovoltaic module, or generally in general language it is said it is a photovoltaic plate. Plate is nothing, it is basically module. So smallest unit of one particular PV module, it is called solar cell, right? Now here you can see it is a module. Module is what? So you can say module is nothing. It is a basically interconnection of different solar cell, right? Now this solar cell may be either connected in a series or it may be connected into parallel. It depends. So we say, suppose we talk about one single solar cell. So you get from the one solar cell output voltage is, or you can say this open circuit voltage is 0.5 volt and current is 4.4 ampere. It is always at standard test condition. Now by single solar cell, just you are getting a 0.5 volt, right? Now suppose you need a 18 voltage. So how many solar cells are required? Because from one solar cell, you are getting a 0.5 volt and now you need a 18 volt. So what you will do? 36 divided by 0.5, so it comes 18. That means if 36 number of solar cells are connected in series, then you will get 18 volt. Now because all cells are connected in series, that means current will be same. It is very simple formula. I think you are able to understand. You have read in class 10th and 12th also. So whenever solar cells are connected in the series, that means voltage will be added and current will be the same. So output current of one solar cell is 4.4 ampere current and output voltage is, or you can say open circuit is 0.5 volt. So 36 solar cells are connected in series. That means you will get 18 volt. That is open circuit voltage and current is 4.4 ampere. Now you have understood what is a solar cell, what is a PV module. Now you can understand what is an array. So array is nothing. It is a basically interconnection of different PV modules connected in some manner. It may be connected in series or it may be connected in parallel. Now how it is connected in series or it may be connected in the parallel, it depends basically how much voltage is required and how much current is required. Suppose you need more voltage, like suppose if we talk about our domestic power supply, how much voltage is required for household supply? It's nearly 230 voltage, 240 voltage. That means how you can decide how the PV modules will be connected in series or in parallel, because 230 voltage is required and you know this PV module is giving 18 voltage, and so how many PV module is need to purchase from the market? 230 divided by 18. So just you can find out the number of PV module, how many number of PV modules are required to get 230 voltage. So now you are able to calculate number of the PV module and all are connected in the series. That means again current is 4.4 ampere and voltage is 230 voltage. So what will be the power? Power is equal to what? Power, as I already told you, power is, it is a product of voltage and current. I am neglecting the value of the fill factor here. So that means 230 multiplied by 4.4 ampere. Now sometime you need more current, because whenever say that electrical load is increasing or decreasing. So load is nothing but basically it is a current. So that means if demand, or you can say magnitude of current is increasing, you can say the value of the current is increasing. Sometimes you need more current, like 8.8 ampere current. So what you will do? Suppose you are able to calculate that 15 modules are required to connect 230 voltage. Now you need a 8.8 ampere current. That means string of 18 PV modules which are connected in series, similar strings are required, and now both are connected into parallel, right? So this is how you can find out how many number of PV modules are required and how you will connect in series or in parallel. Here you can see, basically here you can see this is a semi-transparent PV module and this is a opaque PV module. So just you have to understand what is a semi-transparent PV module and what is a opaque PV module. I think audience is from science background.
Sir, from all background.
From all background.
Acha, all
From all
level.
background. So we'll have to.
I'm not going in the detail in the engineering. I will
Yeah,
I
that
will
will
cover
be
very
better.
simple, right?
That will be better. Yes.
You will be able to understand. So just you can understand by the name semi-transparent, right? Semi-transparent means this one is a basically solar cell. This black one. So these solar cells are basically sandwiched between you can say two medium. If upper layer is a glass and lower layer lower portion is also glass, and some just you can understand these are type like a bread, right? These are the bread and it is placed in this manner. Now all breads are sandwiched between two glass. So what will happen? It will be called semi-transparent. That means what will happen? If solar radiation is coming, that means if solar radiation is incident on this black portion, so it will be converted into electrical energy. Now what about this portion? Here you can see this one is white one. So because it is a glass, so glass is basically transparent. That means some light will be transferred from top surface of the PV module to the back surface of the PV module, right? So this type of PV module is called semi-transparent PV module. Now what is the beauty of this semi-transparent PV module? One is because main focus or main aim is to get the electrical energy from the PV module. Now this semi-transparent PV module can be placed where day lighting is required. That means where lighting is required. Suppose this can be placed in the some parking portion, or such type of semi-transparent PV module can be, it can be work as a glass of the window. Because what is the use of the window in house? What is the use of the window? That means this some day lighting should transfer from outside to the inside of the room. Now this glass window can be replaced from this semi-transparent PV module, right? So what will be the use? This will convert solar energy into electrical energy. At the same time, some light will transfer from outside to the inside of the room. That means you do not need to require to switch on some LED or CFL or this tube light to get room illuminated, right? If natural light is coming inside of the room, that means you are not going to use any electrical lamp. That lamp is on from the conventional power supply. If you are switching on all the lights, that power is coming from thermal power plant. So what will happen? That means this thermal power plant, of course, this thermal power plant is giving electrical energy, but at the same time, that thermal power plant is emitting some carbon. That means if it is emitting some carbon, that means it is polluting to the environment, right? So just you need to understand one basic formula. I think then you will be understand what is the use of this solar PV. I think you can understand 1 unit of electrical energy. What is the meaning of 1 unit of electrical energy? Just you try to understand. Always, whatever the electrical will come in your household, it is always multiplied by unit. And unit means, suppose you are using 1 unit of electrical energy and cost of that 1 unit is suppose 5 rupees. That means you are going to give 5 rupees for that particular 1 unit. Now you have to understand what is a 1 unit. 1 unit means if you are using any electrical appliances, whether it is refrigerator or fan, cooler, AC, washing machine, any appliances, and the capacity or power rating of that particular appliances is 1 kilowatt, or you can say 1000 watt, and you are using that particular appliances for 1 hour, that means 1000 watt multiplied by 1 hour, so it is come 1000 watt hour, and just you divide by 1000, so it comes 1. So unit will be what? 1 kilowatt hour. So always if we say that you are using 1 unit of electrical energy, that means you are consuming 1000 watt in 1 hour. That means you are using 1 unit of electrical energy, right? Now how you can understand? Because mostly we person use the AC, and if you are using 1.5 ton AC, right? So 1.5 ton AC consumes 2000 watt of electrical energy, and that AC is on for 1 hour. That means you are consuming 2 unit of electrical energy. Am I clear? That means you are consuming 2 unit of electrical energy. Now just you try to understand. If you are using 1 unit of electrical energy and that is coming from thermal power plant, that means you are emitting for 1 unit electrical energy at your home. That means you are emitting 2.08 kilogram carbon dioxide emission. You are using 1 unit of electrical energy at your home. That means you are emitting 2.08 kilogram carbon dioxide emission. Now suppose just you are using 1.5 ton AC and it is consuming 2 unit of electrical energy. That means approximate you are responsible, not you are emitting, you are responsible in the environment to emit 4 kilogram carbon dioxide emission, right? So in reverse of that, you can understand, if you are using or you are using 2 unit of electrical energy from photovoltaic solar cell or photovoltaic PV module or photovoltaic PV array, that means you are saving 4 kilogram carbon dioxide emission for using that 1.5 ton AC for 1 hour. Now just you can calculate the electrical load of your home. At any home, suppose you are using 1 AC, that means 2000 kilowatt, then you can calculate number of CFL, your load of refrigerator, your TV, your washing machine, microwave, all our electrical appliances nowadays have become a part of the life. That means approximately, generally, the load of at any small house, it is 5 kilowatt, right? So 5 kilowatt, that means you are using 5 unit of electrical energy per hour. That means you are emitting 10 kilogram carbon dioxide emission per hour. Just you can understand, or just now you multiplied by 12 hours, then you multiplied for particular 1 month, then you multiplied by 12. Then you will be able to calculate how much carbon dioxide you are responsible to emit the carbon dioxide emission, right? So my advice is, if you are using, so just I am trying to understand what is the use of this semi-transparent PV module. So this semi-transparent PV module is responsible to generate electrical energy at the same time, because you are making a window of this type of semi-transparent PV module. That means natural light is coming in the house. Now suppose for that particular, whatever the illumination you are getting by this one window, and now you can just close this window and just you have to find out how much CFL is required. So you can calculate the electrical load. suppose you are using 2 CFL or LED, just simply you can understand 20 watt. So that means you are saving 20 watt of electrical energy by this type of system, by using this type of semi-transparent PV module, right? Now again we will understand what is the use of this. Another type of PV module is opaque PV module. Opaque PV module is means back surface of the PV module is non-transparent and top surface is a semi-transparent PV module. Now, whatever I was explaining in my first slide, just you try to understand this slide, then you will be able to understand what I was trying to explain. Here you can see, just this is a one photograph. This is a semi-transparent solar cell, only solar cell, not a PV module. That means one single solar cell. So what I did basically, just I made a one channel below the solar cell, and I was trying to force the air below the channel, this solar cell, and here you are collecting the hot air. So what will happen? This ambient air will come in the contact of the base of the solar cell. So heat will be transferred from solar cell to this air. That means this temperature of the air will increase. At the same time, temperature of the solar cell will decrease. If temperature of the solar cell, suppose you are able to decrease 2 degree temperature of the solar cell. So what you can do? You can say you can increase 0.8% electrical efficiency of the solar cell, right? At the same time, what is happening? You are collecting hot air at this point. So basically hot air is what? Hot air is nothing. It is basically thermal energy. If you are able to recall the very basic formula that we read in class 9th, I think, that is a Q is equal to mc delta T. I think you are able to recall Q is equal to mc delta T. This M is nothing. It is basically mass flow rate, right? And C is what? This is specific heat of the air. And delta T is what? Delta T is nothing. It is basically difference of the temperature. Difference of the temperature means this temperature hot, you can say this temperature is T2 and this temperature is T1. Of course, this temperature T2 is more than this T1. So if there is a difference in the temperature, that means you are getting some hot air, and that value is equal to Q is equal to mc delta T. And this M is what? Basically, it is a mass flow rate. At which rate air is flowing in the duct, that is basically called mass flow rate. And this mass flow rate also depends on the different parameter. It depends on size of the duct, what is the length, what is the breadth, at which velocity air is going inside, right? So basically that formula is mass flow is rho AB. Rho is a specific density of the air. A is area of this particular duct, and V is velocity of the duct, at which velocity air is going. So air can be forced with the help of the fan. So this will be this type of forcing of the air will be called forced air. If air is coming in naturally, that is called natural circulation. So suppose you are sitting in the room and there is no electricity. So what will happen? And at the same time, sometime air is coming from the window. So that air touch your body. So what happens? That heat transfer from your body to the air. Then you feel the cooler. Then that means you are feeling very comfortable. That means suppose you are sitting in the 27 degrees centigrade, or just you can say 35 degrees centigrade or 38 degrees centigrade, and by any means this temperature can be decreased 36 to 34. That means you will feel comfortable. Similarly here, this air is coming inside of the duct, so heat will be transferred from the back surface of the temperature to the air. So what will happen? That means you are able to decrease the temperature of the solar cell. That means you are able to enhance the electrical efficiency of the solar cell. Now, I'm not trying to understand and going to explain this formula. So here you can see. Now, because every time I was saying that with this hybrid photovoltaic thermal system, you are getting a two type of energy. You do not need to understand this formula, right? I'm just trying to explain you by very simple way, because you are getting a two type of energy from this particular system. One is electrical energy, another is thermal energy, right? So suppose someone is asking how much energy you are getting. So you cannot say we are getting so much electrical energy, right? So you can understand like this. Suppose you have 1000 rupees and you have $5, right? And someone asks how much money do you have total. So what you will do? Either you will convert dollar into rupees and then remaining rupees will be added this converted rupees, then you can say so much rupees we have. Or what you will do? You will convert rupees into dollar and this converted dollar will be added into the rest of the dollar, right? In this way, you can say so much rupees we have, so much dollar we have. Similarly, if you have some electrical energy and you have a thermal energy, so this is a one formula by which you can convert. You can say this is equivalent electrical energy or this is equivalent thermal energy. So you do not need to understand this formula. Here you can say, here you can see this particular two diagram. I think you will be able to understand what I was again explaining. This is air is coming. Here air is coming in the contact of the base of the solar cell. Now heat is transferring from the to the air and you are collecting the hot air. So this is called hybrid photovoltaic thermal air collector. Now air is being used as a medium to decrease the temperature of the photovoltaic module. Similarly, by another way, you can force the water below the PV module. So what will happen? This normal water will come in the contact of the base of the solar cell. That means heat will be transferred to the water and you will get hot water here. So it will be called hybrid photovoltaic thermal water collector, right? Now just you try to understand, because whatever the air or you can say water you are using, basically it is just a, you can say wastage, right? Because you are not using. Now suppose you can use this hot air or this hot water for any meaningful purpose. That means what you can say, this is a useful energy. Now electrical energy and thermal energy, it is added. So you can say the overall efficiency of the system is increasing. Now you have to understand what is the use of this hot air. Now suppose you are making a very big system, right? Suppose you are installing such type of hybrid photovoltaic thermal system at your home, right? And if you are staying in the cold climatic condition like Srinagar, or in fact Guwahati also comes in the cold climatic condition. So the outlet of this hot air can be integrated to the room, right? So this will become as a building integrated photovoltaic thermal system. So what is the use? This hot air is increasing the room temperature of that particular room, right? Suppose this temperature, you can decrease 5 degrees centigrade temperature of the room, right? And this 5 degrees centigrade temperature, now just you try to understand reverse of that. Suppose you have to increase 5 degree temperature of the room by electric heater. If you are using suppose 2000 watt heater to increase the temperature of the room, that means you are using 2 units of electrical energy to increase the temperature of the room. That means you are emitting 4 kilogram carbon dioxide emission. Now by such type of system, this 5 degree centigrade temperature increasing by this hybrid PVT air collector, That means you are saving 4 kilogram carbon dioxide emission. At the same time, whatever the electrical energy that you are getting, it is basically free. That means just you have to invest one time to make such type of system, and suppose after some 4 year or 5 year, whatever the energy you are getting, basically it will be free. Now you can understand this PVT water collector. Now suppose you want to take the bath. Generally we use the hot water for the bathing purpose. Now such type of system can be integrated at your home, and this hot water can be used for the bathing purpose or for washing the utensils. That means now just again you will try to understand. Now this hot water is being used from the geyser. That means this geyser is being run from the conventional system. That means you are using some electrical energy from the thermal power plant. Again, you are emitting the carbon dioxide emission. At the same time, whatever the electrical energy that you are using, that is coming from the thermal power plant. So that is a polluting the environment. Now, such type of system can be made. It will be a hybrid PVT air collector or hybrid PVT water collector. That means you are, by some means, you are contributing to the environment. You are not polluting to the environment, right? Now what I did basically, because whatever I'm saying, I am not here trying to understand the basically what are the different equations, what is the physics behind this, because there is a mix of the audience, right? So whatever I was saying, just what I did basically, just I have taken one solar cell. Here you can see this is a practical model that I did during my research. This is a solar cell, and just this solar cell, basically you cannot purchase one single solar cell from the market. So by some contact, just I went, there is a one organization that is called Center for Electronics Limited in Saibabad. It is near to Ghaziabad. And with the help of the carpenter, I made one channel below this particular solar cell. Here you can see this one. This is basically duct, and here this hot air can be collected from this pipe. So just you can understand this view, you can say. Now here you can see this is a one fan, and that fan I am taken from the CPU of the any fan that you can say that was a wastage, or you can say kawada. So this fan was used to force the air below the PV duct, or you can understand by this orthographic view. Here you can see that this fan air is coming from this way, and it is coming from this particular point. So you can say this is a cross basically. Whatever we say there is a cross ventilation is there or not. The cross, what is the use? This duct can be made here also, but then what will happen? Because whether it is a current, whether it is water, whether it is a air, it is always passes through the least resistance path, right? So if this duct is here, that air will be transferred from this point to this point. That means whole area of the surface of the PV cell will not come in the contact of the air. That means the temperature of the solar cell, you will not be able to decrease the temperature of the solar cell. So this is a basically one picture. Here you can understand. After that, what I did, I connected two solar cells in the series, because I need to basically experiment for one particular PV module, but it was very difficult to get one PV module such type of 36 solar cell. So I requested two PV solar cell, then it is connected in the series. Then here you can see, basically it is two solar cells are connected in series, and here you can see there are 36 number of halogen lamp. Now you will say, what is the use of the 36 halogen lamp? Basically the drawback of the solar cell is what? You need a sun, and during the research, just I was trying to experiment what result will come. Either I have to depend on the sun. So for that, for the experimental purpose, what I did, I made one artificial solar. So these 36 solar lamps were used, or you can say that is a basically artificial solar simulator was made, right? So these lamps are working as a, you can say, replacement of the sun. And here you can see this is basically one mild steel platform on which these solar cells are placed. And now with help of this screw jack mechanism, this sorry. This platform can be up and down with help the screw jack mechanism. Because solar sun always change the position, but here lamps are the fixed. So just you need to change the variation of the radiation. So what you will do? This platform, if you are able to take up or at this point, that means it will come closer to the lamp, that means intensity will increase. So just you need to find out the variation of the solar radiation, or you can understand by this diagram. This is a screw jack mechanism like any jack that you are using in your car. By this screw jack mechanism, this platform can be up and down to change the to see the effect of the variation of the sun. Here you can see there is these are the some instruments that were used during the experiment. Basically, it is a solarimeter, or you can say this meter gives the how much solar radiation is there. And so this intensity can be measured whether it is a 500 watt per meter square or 600 watt per meter square or 800 watt per meter square. So just you need to check one instrument, because if I'm saying, I have told you many times, so if suppose some companies quoting that efficiency of the solar cell is 20%, so it is always a standard test condition. And this standard test condition is if intensity is 1000 watt per meter square and ambient temperature is 25 degrees centigrade. Here you can see this another instrument, that is infrared thermometer. Just it's like a temperature. This torch you were able to see during the COVID time to measure the temperature. Just you click here and you can measure the temperature of the PV module. Just to need to check whether how much temperature of the top surface of the PV module or solar cell. Here you can see this is an anemometer. Anemometer is an instrument by which you can check the at which velocity the air is coming out from the duct, or at which velocity air you are going to force. That instrument is called anemometer. This is a clamp meter. Clamp meter is nothing. Basically, you can understand it is like a multimeter, because if you are going to check performance of the any solar cell, that means you need to check the voltage, you need to check the current, and you need to check the power. So if you need to check the power, so power is what? Power is a product of the voltage and current. So this instrument, by this instrument, you can measure the voltage and current. Then another diagram here you can see, basically it is a constant temperature bath, because I was measuring different temperature at the different point. I was measuring the outlet air temperature, inlet air temperature, back surface of the solar cell temperature. That means for measuring the temperature, you need some devices that is called thermocouples, right? So thermocouples is just like a wire. Now this temperature is just basically with this wire is calibrated by the some standard standard thermometer. Like suppose you are going to purchase vegetable in the market, sometime some that vegetable wala use then some pathar or stone, they say it is equivalent to 1 kg. But you are not confident, so what do you do basically? Just you verify by the some standard weight of that stone. So that means you can say that stone is calibrated that particular weight. Similarly, this all thermocouples are calibrated, and for calibration this you need to take the reading approximately for 24 hours, because you have to increase the temperature from ambient to 100 degrees centigrade, and then it naturally it come 100 degree centigrade to the ambient temperature. These were the instrument you do not need to understand. And this I can skip this slide also. Now here you can see whatever the experiment that I was explaining, that was a indoor experimental setup. Now whatever the result, firstly what I did basically, I developed some equation, and that equation was verified on some software, And according to that equation that I designed particular type of PV module, and that was experimentally validated in indoor condition. Then I used 3 PV modules, all are connected in the series thermally and electrically, and experiment was done for the 1 year. And then I just tried to find out how much electrical efficiency we are getting, whether we were able to increase electrical efficiency really or not, or all experiment that was done, it is basically wastage. So during the experiment for the 1 year, I was able to conclude that we were able to increase the electrical efficiency of that particular PV module. Here you can see, these are the 3 PV modules were connected in series. So here was coming in this way, and this way. Here you can see, this is because if you're using some fan, that means fan will also consume some electrical energy, and that fan was used to force the air inside the duct. That means you are able to enhance so much electrical energy by making hybrid PVT system. Now, what I did, whatever the system that I was using, that was basically, it is a hybrid photovoltaic thermal system. Again, what I did, I pasted some thermoelectric material also. So thermoelectric material is basically what? Just you can understand very simply. If you are placing some thermoelectric material between 2 temperature, means if there is a difference in the temperature, that will give you some electrical output. So it is a property of the thermoelectric material. If you are placing between 2 temperature and there is a difference in the temperature, that means you will get some electrical output. So for this particular, I'm not going to explain here. You can understand this one. So this one is a simple solar cell that you can see in the market or in your nearby place. And then I pasted some thermoelectric, this PV module. So by this pasting some this thermoelectric material, I was able to get some electric metal, and then we were forcing the air below the duct. That means again we were able to decrease the temperature of that particular solar cell. Then again we were able to increase the electrical energy, and we were also able to get the hot air. So suppose we were not using, suppose just now you try to understand very simply. Suppose you are not using this hybrid thermal system, you are not using any thermoelectric material, just you have this one, right? And you are getting, suppose, electrical energy X, or in word you can say understand, just you try to understand. Suppose you are getting 100 watt electrical energy, right? Now, yeah, as I already told you, by making this hybrid PVT system, or you are making a duct, so you are able to get some more electrical output. Suppose you say 5 watt. That means by using this system, you are able to get now 105. Original was 100 watt. Now by making, you are able to increase 5 watt. That means you are getting 105 watt electrical energy. Now you are using thermoelectric material also. By placing thermoelectric material, now you are getting again enhanced electrical energy. Suppose you can say 3 watt, or you can say again 5 watt. That means you are able to get 110 watt. That means if you are not using any research, or you are not trying to apply some technique, whatever the system you are using, just you will get 100 watt electrical power, right? And these at standard test condition only. Now you are using this thermoelectric material or hybrid system, that means you are getting 110. That means some higher side. So in this research, in case of PV system, you will get some enhanced result. That means you are getting 110. That means you have an advantage of 10 watt power. So by this system, now suppose this is talking about this small system. Now we talk about the very big system. This research was done on only 75 PV module. Now suppose this type of system can be made for 1000 kilowatt or 1 megawatt, because from 75 watt you are able to enhance the 10 watt. Now 1000, or you can simply understand 100, you are using 100 watt PV module, you are able to get 10 watt. That means 100, you are getting 10 watt per 100 watt. 1000 watt means 100 watt. That means 10% efficiency can be increased by using such type of system. Now suppose 10%, one megawatt of 10% is basically what? 100 kilowatt. Now 100 kilowatt you are getting freely by applying this research. 100 watt, 100 kilowatt. Now 100 kilowatt multiplied by 1 hour means 100 unit of electrical energy you are getting additionally. If you are getting 100 unit of electrical energy additionally, that means 100 multiplied by 2. That means 200 kilogram carbon dioxide emission can be saved to the environment. Right? So our aim is what? Our aim is to shift from conventional system to the solar PV system. At the same time, as a researcher, as a student, as a faculty, we have to research how we can enhance the electrical efficiency of this particular system. So this is how you can enhance electrical efficiency of any particular PV module. So this is all about the hybrid photovoltaic system. Here you can just, I am not going to explain this. So by this system, you can see there is another term, just you need to understand energy payback time. Energy payback time means, suppose you are making any system because you are using the PV module. For making this particular PV module, again electrical energy is needed. Suppose you use 10 unit of electrical energy for 100 watt PV module. If that 100 PV module is not able to generate 10 unit of electrical energy in throughout the life, that means there is no use of such type of PV system. Or you can say that 10 unit of electrical energy can be generated in suppose 1 year, for example, or 2 years. That means you can say the energy payback time of that particular PV module is 2 years. So after the 2 years, whatever the energy you are getting, that is free. So what the problem we are facing, because initial cost of any particular PV system is costly, so we are not able to shift on the PV. But if you are able to understand that if you are investing some money in the beginning, and after 3 or 4 years, whatever the energy you will get, that will be the free, and you assume that life of that particular PV is 20 years and energy payback time is 2 years. That means for the 18 year, you are getting a energy free of cost. At the same time, you are contributing to the environment. You are not polluting to the environment by using such type of system. Here you can see whatever I was using, that hot air, how the hot air can be used. That hot air, here you can see this one is a PV module, right? So by this PV module, you can get the electrical energy. At the same time, because you are cooling by making the duct, so here some trays are placed, and here some additional plants are placed like mint or tulsi powder, and this can be dried by this hybrid PVT air collector. That means because it is in a force air, that means the dry time of this particular crop is reduced. That means you can dry that particular mint or anything, or you can make the chips, tomato chip, potato chips. You can dry the mint, you can dry the this tulsi, and just you can make a small sachet and you can sell the market in the market. So such type of system can be useful for the some farmer also, and you can understand, or you can only understand what is the use of this PV where there is no electricity. Because suppose we are sitting in the AC room and we are talking about this use of the PV that we cannot understand. Wherever there is no electricity and you are placing this PV module, and by this PV module, if you are able to switch on some one fan or two CFL, that means you can feel what is the use of this PV module. At the same time, you can make hybrid PVT air collector, or some small industry can be placed. Suppose if you are using such type of system, so basically you can make some industry also for making the mint powder or tulsi powder also. Here you can see some chilies are drying by this hybrid PVT collector, and this is a semi-transparent PV module. Here you can see that means natural day lighting is coming from top surface to that particular duct, and this natural light is going inside the building. This is a basically hybrid PVT water air heating system. I have already explained you. This is a building integrated photovoltaic thermal system. So this is all about my research that I have shared with you. That is a hybrid photovoltaic thermal air collector, or you can say hybrid photovoltaic thermal system. So just I tried my best how you can do research on this particular PV system. I think I was able to explain. If you have any question, please ask any question.
Shruti, can I ask a question right
Yes,
now?
sir. Yes, sir.
Okay.
Yes,
please.
of course, please.
Yeah, thank you, Professor Sanjay Agrawal. It was a very interesting presentation. And although not from the science background, I could follow it thoroughly the way you explained it. It was an excellent way of presentation, right? Even for non-science background people also. You have talked about this payback time for energy payback time, right? That period. Basically, as you would also appreciate, the cost is forbiddingly high. The solar system installed in our household. Has there been any breakthrough innovation in the recent years about the reduction of cost in this aspect?
Basically, whatever this research is, basically this is on the only for the research
For
purpose.
your research only, yeah. For this, whatever you have presented is from your research only. From that,
Yeah.
we have got ourselves fully convinced that
Yeah.
it saves energy. At the same time, we can reduce this
Just
carbon.
I would like to add one thing.
Hmm.
Whatever this research is being done, my guide, my mentor, Professor G.N. Tiwari, who was professor in the IIT Delhi, now he's retired. And for contributing to the society, he has shifted from Delhi to his hometown. That is a one home place is Balia, which is in UP, very
Right.
small place.
Hmm.
And what he is doing, and whatever the research he did throughout the life, all research models was made in that particular Blaze, and such type of system that I proposed, that is a hybrid PVT air collector for drying some medicinal plant, he is using, and they are giving some employment to the rural person also. So this
Okay.
is not only for research purpose. Now they are using such type of research on a small scale level.
Okay. At the commercial front, are you aware about some breakthrough innovation that the cost is coming down in using solar systems?
Yes, of course, cost is coming down, because during the research, as I able to recall, in 2009, I purchased one PV module of 75 watt that was coming of 18,000. Can you imagine? You can understand 100 watt PV module, the cost of the 18,000. Now this 100 watt PV module is coming around 6,000 or 7,000 only.
Okay, 3 times reduction.
So during the 10 year, this cost is coming down from 18 to 8. So this is a drastic change. So there is a whole big research is going on, because this research, because whatever I am explaining, it is the application part only. If we are going to the material science, so scientists are working on the material, on how we can enhance the electrical efficiency by using different type of material.
Right. Okay. Thank you, Professor Agrawal. Shruti, you can take care of.
Thank you. So I request the other participants to ask their queries if they have any questions.
Please speak louder. Who is asking? whosoever asking. Please.
So if any of the participants have any queries, please ask. You can unmute your mic and ask the question to sir.
Hello, good evening, ma'am.
Good evening.
Ma'am, I am from Hailakandi district, from fourth semester MSc IT students.
Yes.
Hello?
Yes,
Ma'am,
please ask
can
the
I-
question to sir.
Yeah, can I watch these videos in YouTube? Because I have present these videos after half an hour. Hello, I have joined this video after half an hour.
Yes, yes,
Okay.
you will be able to see this video in YouTube. It will be available.
Okay, thank you, ma'am. Just I want to say another things, ma'am. Just can I ask regarding our project over here? Hello.
Regarding what, sir? Hello.
This is not the right platform. This
If
is
you
not
have
the
any
right
query,
platform.
if you have any queries regarding today's talk that sir has delivered, please ask on those on that subject only.
Okay, if there is no question, then
So,
it's very interesting talk. Yeah.
Thank you very much, sir, for your insightful presentation. I am sure all of us have benefited from your lecture today. I now request Dr. Taposi Kashyap Das to give the vote of thanks.
Thank you, Dr. Shruti Subba Bharali. On behalf of Krishnakanta Hendricks State Open University, I would like to take the honor to offer the formal vote of thanks. At first, I would like to offer my thanks to our Honorable Vice Chancellor, sir, for his constant support and guidance. I would like to thank our respected guest, Professor Sanjay Agrawal, Sarji, for his informative speech on hybrid photovoltaic thermal system and for providing us his valuable time to enlighten us with such a relevant issue. I would also like to thank our respected registrar sir for allowing us to organize this event and extending all necessary help for the same. I would also like to thank all the senior authorities of the university, faculty members, officers, and participants who attended this talk to make it a successful event. I also offer my thanks to the members of the IT cell for extending their technical support for the smooth conduct of this virtual lecture. Thank you, sir, and thank you all the participants.
Thank you. Thank you very
Thank you.
much.
Thank you, sir.
Thank you.
Thank you,
Thank
sir.
you. Thank you.
So we can end the session now. Thank you so much, sir. Okay.